All right, in this video, we are going to focus on what slope represents and what the y-intercept represents and what the x-intercept represents. So not so much just on the math computation of what the numbers are, but what do they mean in the problem. So our first one here, Carl filled up his gas tank of his truck and then he sent out to deliver a shipment of bananas to Alaska. The graph shows the amount of fuel remaining in the truck's tank in liters as a function of distance driven in kilometers. So what it has told us at the beginning here is that we know that our x value, our independent variable going across the x-axis, the horizontal axis, is kilometers, and that our dependent variable going on the y-axis, the vertical axis, is in liters. And so there are three things we want to pick out and interpret. We want to look at what is the y-intercept, what does it mean? The x-intercept, what's it mean? Where is it located? And the rate of change. We want to interpret that, what's it mean in this problem. Okay, so let's start with the y-intercept. The y-intercept occurs right here. The y-intercept is the place where our graph crosses over the y-axis. And so if we look at the point that's there, that point that would be there is the point 0, 400. And that is the point that is the y-intercept, the value of y when x equals 0. What that means in our problem, if you think about what the x value and what the y value represents, that this is how much gas our tank starts with. So it starts with 400 liters when they start measuring the time. And so, or when they start measuring the distance, excuse me. So at 0 kilometers, the tank has 400 liters. So it's the starting value of the gas in the tank. If we look at our x-intercept occurs down here. And that is the point 500, 0. And this is the x-intercept, the place where the graph crosses over the x-axis, or the value of x when y equals 0. What this would tell me is that it takes 500 kilometers for there to be 0 liters of gas to use all of the fuel in the tank. How much fuel was in the tank? 400 liters. Our last thing we want to look at here is our rate of change. Rate of change is our slope. And so if we look at this, it's going downhill. And so we're going to say that that's a decrease. And it's a decrease of, think about the change in y over the change in x. It's a decrease of the amount of liters of gas per the amount of kilometers driven. And so although we're not going through and finding these values, finding the rate of change, we're working on interpreting them. What do they represent? What do they mean in the problem? So let's take a look at another one here. So Sean tried to drink a slushie as fast as he could. The graph shows the amount of the slushie left in the cup in milliliters as a function of the time in seconds. So here we are told that if we're looking at this problem, we know that our x value, our independent variable, is the amount of time that's being measured in seconds, and that our y value is the amount of slushie that is in the cup, and that is being measured in milliliters. And so if we go to look, we want to do our same three things again. We want to look at what is the y-intercept, what does it represent? What's the x-intercept, what does it represent? And what's the slope represent? Excuse me, what does the rate of change represent? Okay, so if we go to look at the slope at the y-intercept occurs right here, and that is the point 0, 250. And so what that tells us is before Sean starts to drink, when time is 0, there's 250 milliliters of slushy in the cup. So it's the amount of slushy that Sean starts with. So I'm just going to write that it's the amount of milliliters in the cup at the start. If we go to look down here, right here is our x-intercept, and that is the point 50, 0. And what that tells us that it takes 50 seconds, it takes Sean 50 seconds to drink the entire slushy what was in the cup. So what does it mean? It takes 50 seconds for Sean to drink the amount of slushy that was in the cup. And then our rate of change, of course, is decreasing because the amount of slushy that's in the cup is decreasing as Sean drinks. So we're going to say that it is a decrease in the amount of the slushy, and that is in milliliters per second. So we've interpreted what the y-intercept, the x-intercept, and the rate of change, what they represent in this problem. So with this video, we're trying to go just beyond the numbers and what's it mean? What's the meaning behind it in the problem? And here's our last one that we're going to look at. It says, instead of giving a graph this time, we're given an equation, a function. It says the function below shows the cost of an ice cream sundae with different number of toppings t. Okay, so I'm going to rewrite this just so it's a little bit larger and I have some space down here. So f of t is equal to 0.75 t plus 2.25. So we're going to do the same things, except we don't have a graph, so we have to use a little bit of interpretation, okay? So if you think back to what we know about function notation, that this is really just slope-intercept form. It's just written a little bit differently. So when we look at our y-intercept is b, this is our y-intercept right here. And so in this particular problem, that $2.25 represents the cost of the sundae. The basic cost if you get the basic sundae. So this is the y-intercept, the cost of a basic sundae, plain sundae, whatever you want to call it. Okay. Now, to that, if you want to, you can add some toppings. And that's what t represents in our problem. If you go back and look at the original here, look at what's given to us, this t represents the number of toppings. And so that's what we have there, the number of toppings. But what we want to look at is this right here, which is our slope, our rate of change. And what that actually represents, it's an increase, and it's an increase based on the number of toppings. Okay, so it's 75 cents per topping. So it's an increase of 75 cents per topping. And if we think about this over here, what's this part of the problem tell us? This part is our total price. Total price, total cost of the sundae. You know, if you just want the sundae the way that it comes, it's $2.25. But for each topic that you want, you have to add 75 cents on there, and that's that rate of change.